Good afternoon everyone and welcome to our final year Honours Project Design Seminar for the Emergency Services Personnel Network. ESPN, the Emergency Services Personnel Network. It is a network of all individual officers who will be issued with our device and was designed specifically with the police force in mind. The device constantly monitors their movement and determines if they are in need of assistance, either automatically or because they've hit the panic button. Should it determine they are in need of assistance, a buzzer will sound, the assistance light will come on, and it will automatically update a server with a Google map indicating their exact location. This improves emergency services efficiency because they can automatically direct the assistance to the exact location of where the officer is. We pursued this project because we see a need for the system to immediately organise assistance for those who cannot organise it for themselves because they are unresponsive. The ESPN has the potential to save lives, and that's its major strength. I will give a short overview of the system now, then we'll have a short 5-minute video demonstration of some of the benefits of the system, and then we'll get more into the technical reasonings behind the system. So our objectives were to design a device for emergency service personnel that utilised GPS technology, utilised accelerometer data, incorporated a panic button, fits comfortably on the body, and communicates back to a server in order to update a map in real time. The main focus of our objectives was to create a prototype in terms of testing the concept of our emergency service personnel network. So how the system works. The system constantly monitors the police officer who is meant to be standing here in this diagram. It constantly tracks his position and then relays that data to the police car. Unfortunately, something has gone very wrong with this diagram. There is a police officer there and then it re-references the car. We'll get into the details of why we send this transmission to the car later in the project. It then goes to the preferred police communication network back to headquarters to update the server with the map. If the device determines that the officer is in need of assistance, it will then automatically update the map with the status, allowing headquarters to organise assistance to the direct location of the officer. We will now have a short 5-minute presentation to highlight the benefits of the device.
This is Officer Phillips. I've apprehended the suspect. I'm on the corner of... I have no idea where.
This is headquarters. Don't worry, Officer Phillips. Thanks to the Emergency Service Personnel Network, we have your exact GPS location. Backup is already on its way.
Thanks ESPN.
Attention all units, Officer Phillips is down. Ambulance en route to the alleyway alongside 21 Archer Street, North Adelaide. The officer is 5'6", blonde hair. Officer is blood type B with known respiratory problems. Priority 1, officer down.
Use your money, man. Good.
Police, freeze!
I've lost the subject. Somewhere now. Use your money, man. Good.
Police, freeze!
This is headquarters. Officer Phillips is in distress. All units provide assistance to Curtis Street, North Adelaide, heading westbound.
Okay, that was a quick demonstration of our video. Currently up on the PowerPoint slide here, we can see a prototype of our actual device, an image of it. This prototype actually contains 2 push buttons which act on a dual purpose to signify for the panic, as shown in the video. It also has 4 LEDs, one indicating the power to the system, accelerometer and GPS data is being sent and received to the actual main board itself, and assistance is required, as also shown in the video. The current casing is quite durable at the moment for all the testing purposes that we need it for, and also up the top has the power inputs for charging the batteries. Currently here, the final product for our Google Maps display, as shown in the video also, it's a current screen capture of the Google Maps software, showing a marker representation of the individual device at its corresponding location. For the purpose of this demonstration, we actually used just a laptop to act as the server itself. We've also introduced a new feature in the recent weeks, which actually displays all the personal details, which is linked through a MySQL database. Further into this presentation, we'll go into the hardware and software further.
Okay, now we're going to look at the background studies and research that we did before we actually began building the device. First of all, we interviewed Police Sergeant Brett Mitchell, who's located at the Christie's Beach Police Station. From discussions with him, we found out about their current emergency procedures. At the moment, they use a panic button on their radio that once they press clears all radio channels, and the officers are required to give the location as well as some information about the incident over the radio. He did also let us know that they, in the next 2 years, will be adding low-jacked GPS devices into all of their cars. At the moment, the officers aren't overly happy about putting that into their vehicles, as they don't want to be tracked during their entire shift, but they will put it in there anyway. He also raised concerns about, in the stakeout situation, as you heard in the video, there is a buzzer enabled on the device. In a stakeout, if you're obviously waiting for a criminal or a suspect, you don't want to have a buzzer going off every 30 to 50 seconds. And the other useful bits of information he gave us were some parameters for the device, namely the battery life. An officer shifts about 8 hours, of which they spend about 2 hours doing paperwork and other tasks. So we've designed the device with a 6-hour battery life in mind in full operation. as well as allowing a 9 to 10 battery life extension using other power saving techniques. He also told us that the officers on average don't try and go more than about 400 metres away from the car. Next we talked to Cameron Stott, who is the Occupational Health and Safety Officer at the Adelaide CBD Fire Station for the Metropolitan Fire Service. In discussions with him we again found out their current emergency procedures. He informed us that at all firefighting situations they have a fire operations manager who's located just outside the fire, and his job is to keep track of all personnel inside and exiting the fire, as well as being in command of all communications. All officers, when they're in the fire, work in pairs. If one of the officers falls down, regardless what the situation is or the reasoning behind that, a mayday call is made over the radio. The fire operations manager then finds out where the officer's fallen down and sends in a specialised mayday team, which is next to him at all times in the fire. He also made points about the device in that the extreme temperatures involved with firefighting need to be taken into account. So all firefighting equipment has to be tested to the ISO standard of about 250 degrees Celsius average temperatures and be able to last flashovers of 1300 degrees for a few seconds. He also made a point about the dexterity of the unit, and that comes down to the customisation of the unit for the specific services, which we'll discuss a bit later, in that the firefighters use very bulky gloves that mean they can't interact with small buttons on the device. So obviously larger buttons need to be used, as well as removing snag hazards for situations where an officer falls through the floor and are trapped up in wires. He also made a point of saying that the device would be better suited to the country fire service, as they tend to fight fires in open field situations, whereas the MFS tend to only fight fires indoors.
Further research that we did before taking on the project was to download and read the South Australian Police Department annual reports for the 08-09 and 09-10 financial years. Some of the findings from the reports was that in the 08-09 financial year there were 871 assaults on police officers. Now these assaults ranged anywhere from minor assaults with officers simply being pushed over to serious injuries. There were also 2,700 resists of arrest or attempts to hinder police activity. These were potentially more dangerous situations that officers deal with every day. Further studies revealed that there were 34 escapes from custody and 3,700 weapon offences. This really emphasised to us the need for an emergency service personnel network, because officers, particularly star group officers, are working in dangerous environments with high potentials to render them unconscious or unresponsive and unable to call for help themselves. The ESPN has potential to save their lives. Further studies we did was we read the IEEE document titled Accelerometer Signal-Based Human Activity Recognition Using Augmented Autoregressive Model Coefficients and Artificial Neural Nets. What this means is that it was a study into accelerometer data and human movement. The document outlines how the accelerometer data indicates different positions people are in, whether they are lying down, standing up, or moving. From reading and studying this document, we came to the result that the optimum situation to determine when someone is in maximum need of help is when they're actually not moving at all. If they're unconscious and unresponsive on the ground, they're not moving, and we can determine that that's the time of most need. We also researched the Google Maps API.